Alright folks, this is Tom from anti-proton.com, and as you can see from my phone right now, it is raining, it says. I'm hiding where it shows that exactly I am, but it uses GPS to figure me out. So anyway, it's raining right this moment, and hold on a second, let me take my phone thing and let you look out my window. And go over here to my window, and as you can see, it is raining nicely. In fact, I'll open the door. See all that water rushing. So anyway, it is definitely raining right this moment. I can put my camera back, and as you can see, I have collected samples. Let's see what's in them. Right off the bat, I've already tested them, and I know that they're radioactive. And this one I took early on. It's a paper towel, as is always used, off the car. And then this guy right here, which is leaking, is also from a car too. Now let me show you. Let me get a paper towel here and wipe this off. It has got some water on it. And you all should probably know I'm not afraid of this because I know pretty much what it is. Of course, I always test for it regardless. But here's the piece of plastic that I'm going to test on. And as you can see, not too much. But then again, why would it? It's a piece of plastic. It's mostly hydrocarbons. As for the area that I'm going to test, oops, let me put that up here. As you can see, we're not really getting too much. Because we're not going to get too much, because we're testing what's in the water. Now, here's the container. Alright. Make sure you can see the Geiger counter. Not much, but some. 92, 98, 114. Now the scintillator is currently running a test right this moment on some sand, but at 9 p.m., which is, you see how long it is till 9 p.m. 7:43 p.m. So in an hour and 15 minutes this goes in the scintillator, and I'll show you the results. I'll post this video tomorrow, and it will show you what was in the water. So we're getting like maybe 150 off of this. And as for this guy, what are we getting? I like these containers, but they're a bit hard to open. About the same amount, maybe a little less. Alright, now here's an interesting question. What is causing this? Are we dealing with the water? Be careful because my Geiger counter's there. In fact, let me lift the Geiger counter so it doesn't get wet. Here's the paper towel. And there's the water. So the paper towel seems to be doing the most. There's nothing in the paper towel. As you can see, it's flat, 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 flat. And it should be pretty uniformly distributed, right? Maybe not so much right there. Maybe more right here. Alright, what's in there? There's a big dark spot, maybe. Well, anyway, so I'm wiping it off my car. Now, what happens when you wipe it off the car? I've been reading about this a little bit, and apparently, apparently there's some evidence that the material, the bismuth 214, lead 214, etc., stick to metal pretty well. And I guess that makes a reasonably decent sense. They are metals. I needed to find out whether or not either of those two are capable of electromagnetic binding. It's hard to take a guess as to why that could be the case. But I'm going to go outside and get a sample of water that fell straight from the sky and is not on a car, and we're going to test that. So let me run outside and grab that and see what we get. And let me first clean that up. I'll be right back. Alright, I'm back. Here's the water. Look at that, it has a little characteristic droplets all over because I just got it from outside. Now, not too much. So it seems to do better coming off the cars. I still wonder if this has anything to do with car exhaust in general. So what I'm going to do tomorrow, after I'm done running this and before I post this video, is I'm going to take a car, wipe a dry car off and see whether or not the soot on it does anything. It would be amusing if it was the soot. But anyhow, now before we throw this in the scintillator and test it, well not this, it's useless, but the other ones over here, let me show you a sample of uranium. One of my million samples of uranium. And as you can see, it behaves quite obviously and characteristically when it's near the Geiger counter. No doubt. So let's see if this, more or less, is what is in this. Let's find out.